Hello students, welcome to Digital Learning. This is Data Communication and Computer Networks, Paper 3, Unit 1, Data Communication. At the end of this session, you should be able to know about data communication, know about modes and type of data communication, know about different types of communication, know about parallel and serial interfaces, understand about different transmission modes. Last but not the least, uses of multiplexing. So let's come to the topic. What is data communication? Here, the word data communication is the combination of data and communication. So, what is communication? Communication is a process of exchanging information from one point to another point. If it is in the form of data or bit, it is called as data communication. Coming to the definition of data communication, it refers to the exchange of data between a source and a receiver via form of transmission media such as a wire cable. Data communication is said to be local if communicating devices are in the same building or a similarly restricted geographical area. Data communication is much like regular communication among people, which consists of following parts or elements. The four elements needed for a communication system are sender, medium, receiver, and protocols. First is sender. The computer or device that is used for sending data is called sender, source, or transmitter. Medium. The means through which data is sent from one location to another is called transmission medium. Receiver. The device or computer that receives the data is called receiver. The receiver can be a computer, printer, or a fax machine. Protocols. There are rules under which data transmission takes place between sender and receiver. Methods of data transmission. Data be transferred from one device to another by means of some communication media. The electromagnetic or light waves that transfer data from one device to another device in encoded form are called signals. Data transmissions across the network can occur in two forms: analog signal, digital signal. What is analog signal? The transfer of data in the form of electrical signals or continuous waves is called analog signal or analog data transmission. An analog signal is measured in volts and its frequency is in hertz. In signaling, there are advantages as well as disadvantages. Advantages of analog signaling. It allows multiple transmission across the cable, suffers less from attenuation, which means reduction of force or effect. Disadvantages of analog signaling. Suffers from EMI, electromagnetic interference. It can only be transmitted in one direction without sophisticated equipment. The second type of signal is digital signal. The transfer of data in the form of digit is called digital signal or digital data transmission. Digital signals consist of binary digits 0 and 1. Electrical pulses are used to represent binary digits. Data transmission between computers is in the form of digital signals. Advantages of digital signaling. Equipment is cheaper and simpler than analog equipment. Signals can be transmitted on a cable bidirectional. Digital signals suffer less from EMI. Disadvantages of digital signaling. Only one signal can be sent at a time. Digital signals suffer from attenuation. Coming to the next topic in this unit, types of communication. A communication network is a set of devices often referred to as nodes, connected by communication links. It provides a service, the transfer of information between users at various geographical points. There are two types of communications. First is point to point communication, second is point to multi point communication. Coming to point communication. A point to point communication is a dedicated communication link between two systems or processes. Think of a wire that directly connects two systems. The systems use that wire exclusively to communicate. The opposite of point to point communications is broadcasting, where one system transmits to many. The next is point to multi point communication. Point to multi point communication refers to communication that is accomplished through a distinct and specific form of one to many connections, offering several paths from one single location to various locations. Point to multipoint is generally abbreviated as PTMP, P2MP, or PMP. PMP communication is commonly used in telecommunications. Next topic, modes of data transmission. There are three types of communications: simplex communication, half duplex communication, and full duplex communication. Coming to simplex communication is permanent unidirectional communication. Some of the very first serial connections between computers were simplex connections. Second is half duplex communication. A half duplex link can communicate in only one direction at a time. Two-way communications is possible but not simultaneously. Third is full duplex communication. Full duplex communication is two-way communication achieved over a physical link that has the ability to communicate in both directions simultaneously. Next topic is bandwidth. Bandwidth in computer networking refers to the data rate supported by a network connection or interface. One most commonly expresses bandwidth in terms of bits per second. The term comes from the field of electrical engineering, where bandwidth represents the total distance or range between the highest and lowest signals on the communication channel or band. Coming to next topic, various communication channels. There are four types of communication channels. First is coaxial cable, second twisted pair, third microwaves, fourth fiber optics. First, coaxial cable. First invented in the 1880s, coax was best known as the kind of cable that connected television sets to home antennas. Coaxial cable is also a standard for 10 Mbps Ethernet cables. A type of wire that consists of a center wire surrounded by insulation and then a grounded shield of braided wire. The shield minimizes electrical and radio frequency interference. Second is twisted pair. A twisted pair consists of two insulated copper wires, typically about 1 mm thick. The wires are twisted together in a helical form. The purpose of twisting the wires is to reduce electrical interference from similar pairs close by. Third is microwaves. Microwave communication is a method of transmitting information or energy by the use of radio waves whose wavelengths are conveniently measured in small numbers of centimeter. These are called microwaves. Fourth is fiber optics. Optical fiber or fiber optic refers to the medium and the technology associated with the transmission of information as light pulses along a glass or plastic strand or fiber. Next topic, types of data transmission. There are three types of data transmission. First, synchronous data transmission. Second, asynchronous data transmission. Third, isochronous data transmission. First, synchronous data transmission. It is a data transfer method in which a continuous stream of data signals is accompanied by timing signals generated by an electronic clock to ensure that the transmitter and the receiver are in step synchronized with one another. The data is sent in blocks called frames or packets spaced by fixed time intervals. The following is a list of characteristics specific to synchronous communication. First, there are no gaps between characters being transmitted. Second, timing is supplied by modems or other devices at each end of the connection. Third, special synchronized characters precede the data being transmitted. Fourth, the synchronized characters are used between blocks of data for timing purposes. Second type of data transmission is asynchronous data transmission. The term asynchronous is used to describe the process where transmitted data is encoded with start and stop bits, specifying the beginning and end of each character. Third is isochronous data transmission. The isochronous format for data transmission is a procedure or protocol in which each information, character, or byte is individually synchronized or framed by the use of start and stop elements, also referred to as start bits and stop bits. The characters or byte may contain the number of bits required to allow translation of the bit pattern into a group of symbols used to represent letters, that is alpha characters, numbers, numerical values, punctuation marks, control elements. Next topic, types of interface. There are two types of interface, parallel and serial interface. Coming to parallel interface, a parallel interface refers to a multi-line channel, each line capable of transmitting several bits of data simultaneously. Most commonly, personal computers have at least one parallel interface for connecting a printer using a parallel port. The Institute of Electrical and Electronics Engineers in the year 1284 standard specified 5 modes of operations, each specifying a direction of data flow, that is toward or away from the computer or bidirectional. These are compatibility mode. This is the original Centronics parallel interface. Nibble mode. This allowed data transfer back to the computer. Byte mode. This allows data to be sent back to the computer at the same speed the data is sent from the computer to the printer or other device. ECP mode. This stands for Enhanced Capability Port and allows bidirectional data flow for printers and scanners. EPP mode, Enhanced Parallel Port. This uses data cycles to quickly transfer data in both directions at speeds of 500 kilobytes to 2 megabytes per second. Second is serial interface. A serial interface uses a serial port, a single line capable of only transmitting one bit of data at a time. A computer mouse connection is a good example. A serial port is an interface that allows a PC to transmit or receive data one bit at a time. Next topic, multiplexing. What is multiplexing? Multiplexing is a technique of simultaneous transmission of multiple signals over a single data link. It allows the various users to share the channel simultaneously. Data multiplexers are used to share the transmission media. It reduces the cost of transmission media and modem by increasing efficiency of the system. Multiplexing technologies may be divided into several types, all of which have significant variations. They are SDM. space division multiplexing. FDM, frequency division multiplexing. TDM, time division multiplexing. CDM, code division multiplexing. Coming to space division multiplexing. In wide communication, space division multiplexing simply implies different point-to-point wires for different channels. Examples include an analog stereo audio cable with one pair of wires for the left channel and another for the right channel, and a multi-pair telephone cable. In wireless communications, space division multiplexing is achieved by multiple antenna elements forming a phased array antenna. Space division multiplexing. It is the simplest form of multiplexing. In this, more than one physical transmission path are grouped together. It involves grouping many separate wires into common cable enclosures. Second, frequency division multiplexing. The spectrum of each input signal is shifted to a distinct frequency range. FDM, that is frequency division multiplexing, is inherently an analog technology. FDM achieves the combining of several digital signals into one medium by sending signals in several distinct frequency ranges over a single medium. Next, time division multiplexing. Time division multiplexing is a digital or in rare cases analog technology. TDM involves sequencing groups of a few bits or bytes from each individual input stream, one after the other, and in such a way that they can be associated with the appropriate receiver. TDM, time division multiplexing, usually used with digital signals or analog signals carrying digital data. Data from various sources are carried in repetitive frames. Each frame consists of a set of time slots. Each source is assigned one or more time slots per frame. Next, code division multiplexing. Code division multiplexing or spread spectrum is a class of techniques where several channels simultaneously share the same frequency spectrum, and this spectral bandwidth is much higher than the bit rate or symbol rate. Code division multiplex techniques are used as an channel access scheme, namely code division multiple access, that is CDMA. Example for mobile phone service and in wireless networks, with the advantage of spreading intercell interference among many users.